Carbide lamps, or acetylene gas lamps, are simple lamps that produce and burn acetylene, which is created by the reaction of calcium carbide with water. Acetylene gas lamps were used to illuminate buildings, as lighthouse beacons, and as headlights on motorcars and bicycles. Portable acetylene gas lamps, worn on the hat or carried by hand, were widely used in mining in the early 20th century. They are still employed by cavers, hunters, and cataphiles. Mechanism: a mining or caving lamp has calcium carbide placed in a lower chamber, the generator. The upper reservoir is then filled with water. A threaded valve or other mechanism is used to control the rate at which the water is allowed to drip into the chamber containing the calcium carbide. By controlling the rate of water flow, the production of acetylene gas is controlled. This, in turn, controls the flow rate of the gas and the size of the flame at the burner, and thus the amount of light it produces. This type of lamp generally has a reflector behind the flame to help project the light forward. An acetylene gas-powered lamp produces a bright, broad light. Many cavers prefer this type of unfocused light as it improves peripheral vision in the complete dark. The reaction of carbide with water produces a fair amount of heat independent of the flame. In cold caves, carbide lamp users can use this heat to help stave off hypothermia. When all of the carbide in a lamp has been reacted, the carbide chamber contains a wet paste of slaked lime. This is emptied into a waste bag and the chamber can be refilled. Small carbide lamps called carbide candles, or smokers, are used for blackening rifle sights to reduce glare. They are used because of the sooty flame produced by acetylene. History: in 1892, Thomas Wilson discovered an economically efficient process for creating calcium carbide in an electric arc furnace from a mixture of lime and coke. The arc furnace provides the high temperature required to drive the reaction. Manufacture of calcium carbide was an important part of the Industrial Revolution in chemistry, and was made possible in the U.S. as a result of massive amounts of inexpensive hydroelectric power produced at Niagara Falls before the turn of the 20th century. In 1895, Wilson sold his patent to Union Carbide. Domestic lighting with acetylene gas was introduced circa 1894 and bicycle lamps from 1896. In France, Gustave Trover Copyright, a Parisian electrical engineer, also made domestic acetylene lamps and gasometers. The first carbide mining lamp developed in the United States was patented in New York on August 28, 1900 by Frederick Baldwin. Another early lamp design is shown in a patent from Duluth, Minnesota on October 21, 1902. In the early 1900s, Gustave Dalle Copyright N invented the Dalle Copyright N light. This combined two of Dalle Copyright N's previous inventions, the substrate gamma-sun and a sun valve. Inventions and improvements to carbide lamps continued for decades. On March 10, 1925, Andrew Prader of Spokane, Washington was granted a United States patent, number 1,528,848 for certain new and useful improvements for acetylene lamps. After carbide lamps were implicated in an Illinois coal seam methane gas explosion that killed 54 miners, the 1932 Moequa coal mine disaster, carbide lamps were less used in United States coal mines. They continue to be used in the coal pits of other countries, notably Russia and the Ukraine. In the birth of the cinema of Iquitos, a carbide lamp was used as light support to project the first film in the Casa de Fierro, in 1900. Lighting systems. Carbide lighting was used in rural and urban areas of the United States which were not served by electrification. Its use began shortly after 1900 and continued past 1950. Calcium carbide pellets were placed in a container outside the home, with water piped to the container and allowed to drip on the pellets, releasing acetylene. This gas was piped to lighting fixtures inside the house, where it was burned, creating a very bright flame. Carbide lighting was inexpensive but was prone to gas leaks and explosions. Early models of the Ford Model T automobile used carbide lamps as headlamps. Acetylene lamps were also used on riverboats for night navigation. The National Museum of Australia has a lamp made in about 1910 that was used on board PS Enterprise, a paddle steamer which has been restored to working order and also in the museum's collection. They are also used for night hunting in some African countries. Using caving. Early caving enthusiasts, not yet having the advantage of lightweight electrical illumination, introduced the carbide lamp to their hobby. While increasingly replaced by more modern choices, a substantial percentage of cavers still use this method. In cave surveys, carbide lamps are favored for the lead or point surveyor, who must identify suitable points in the cave to designate as survey stations. The sooty carbide flame may be used to harmlessly mark cave walls with a non-toxic and removable station label. Especially favored for this purpose are all brass lamps or lamps made with no ferromagnetic metals, as these lamps do not deflect the needles of a magnetic compass, which is typically red while brightly illuminated from above using the caver's lamp. Apart from their use as cave surveying tools, many cavers favor carbide lamps for their durability and quality of illumination. They were once favored for their relative illumination per mass of fuel compared to battery-powered devices, but this advantage was largely negated with the advent of high-intensity LED illumination. The acetylene-producing reaction is exothermic, which means that the lamp's reactor vessel will become quite warm to the touch. This can be used to warm the hands. The heat from the flame can also be used to warm the body by allowing the exhaust gases to flow under a shirt pulled out from the body, a technique discovered almost immediately by coal miners. See also, Dalla copyright N-light, flashlight, headlamps. Notes. References, Clemmer, Greg. American Miner's Carbide Lamps, A Collector's Guide to American Carbide Mine Lighting. Western Law Publications. ISBN 978-0870260643. Pochts, Henry. The Miner's Flame Light Book. Flame Publishing. ISBN 978-0964116504. Card, Peter W. Early Vehicle Lighting. Shire Publications. ISBN 978-0-7478-0585-4. Thorpe, Dave. Carbide Light, The Last Flame in American Mines. Bergamot Publishing. ISBN 978-0976090526. External links, acetylene.com. A comprehensive guide to the care and maintenance of acetylene gas lamps, a user's guide to carbide cap lamps. Has many good pictures and videos. Carbide lamp demonstration experiment, instruction and video, the Carbide Cave Array website on the history, restoration, and use of carbide lamps for caving.